Jeez, another person dropping a golf ball from a cliff? How dangerous. Here it is. Here's the ground down here, right? Golf ball. It's dropped. Okay, I'm going to take that to mean the initial velocity is 0. It's not thrown down, right? The final velocity, we never say the final velocity is 0. That is it when it hits the ground, right? It's always, the final velocity is always right before it hits the ground. I can then say this is negative 9.8 because we're on Earth. And then the final velocity is 34, but it's down, right? So minus 34 meters per second squared. There it is, right? And then it wants to know how high the cliff is. I think use no t for x, right? So Vf squared is Vi squared plus 2ax. So minus 34, the quantity squared is 0 squared plus 2 times negative 9.8. Uh-oh. Yeah, x, right? Okay, so 34 squared is 1156, right? And that's 2 times negative 9.8 times x. So I'm going to divide that by 2, divide that by 9.8, right? And you get 58.97. 58.979 meters, right? Which you'd round to 59, right? Okay. Then it says, what time does it take to hit the ground? I'm going to use no x, right? So Vf is Vi plus At. All those people need to report to the main office. You got that? Okay, so negative 34 is 0 plus negative 9.8 times t. So I'm just going to go negative 34. So 34 divided by 9.8 basically, right? It's 3.469, so 3.47 seconds. Okay, and these are just, one-off, right? It falls down to the ground and there it is, right? We don't need to double it or anything, right? Okay, so for these guys, when you're dropped, the initial velocity is going to be 0, right? Acceleration is that, and then, just be careful about the displacement. So we had to put the minus sign on there, okay, because it hit the ground going down. There it is.